Alright guys, welcome back to Underground Science, and in this video we'll go over a quick overview of the pH scale. Alright, so the pH scale usually ranges from about 0 to 14. Alright, if the pH, so let me write this down, if the pH is above 7, we know that we have more hydroxyl concentration than we do our hydronium concentration. Alright, or also we can write H plus concentration. Alright, if the pH is greater than 7, we know we have a higher hydroxyl concentration than we do H plus concentration. Because hydroxyl concentration, remember, represents alkalinity. And the H plus concentration represents acidity. Alright, so if we have a high hydroxyl concentration, we know our pH is going to be above 7 if it's higher than our H plus concentration. If our pH is below 7, we know we have a higher H plus concentration in that specific solution than we do a hydroxyl concentration, all right? So that's that, and now let's go and just quickly talk about what the difference in H plus concentration, OH negative concentration is. All right, so if it's a 10-fold increase or a 100-fold increase, because when people talk about the difference in pHs, right, like 7 to 6, that's not a one difference in the number of hydrogen concentration, right, the H plus concentration. That's a difference in 10 times the hydrogen concentration, or the H plus concentration. So let's go and see how that is. All right, so let's go ahead and draw us a number line here. Not like that, sorry about that, I don't know what that was. Okay, so let's go and draw a number line here as best as we can. Right, and let's go and label the middle about at 7, and then we're gonna go, so it's gonna be go to 14, so 8, 9, 10, 11, 12, 13, 14, then this is gonna go to 0, 6, 5, 4, 3, 2, 1, 0. Alright, and now let's go and label this real quick, so this is gonna be 8, 9, 10, 11, 12, 13, and now pH, the pH can go below 0 depending on how high the concentration of our H plus is, alright, but that's only with certain super acidic solutions, alright, but usually it's between 0 to 14, so 6, 5, 4, 3, 2, 1, 0. So that's our pH scale, alright, so this is our pH scale. And so what I want to go through in this video is a basic overview of it. So from here to here, right, so we know that water is neutral, which means it has, and we looked at this in the auto-ionization content of water, right? At 25 degrees Celsius, water has the same amount of hydroxyl concentration than it has, or compared to its hydrogen cation concentration. So 7, the pH of 7 represents neutral, all right? Now, anything above 7 represents alkaline, right? Alkaline, or it's alkaline than normal, and anything below 7 represents acidity. So I should have wrote alkalinity instead of just alkaline, all right? So anything above 7 represents an alkaline solution or alkalinity. Hopefully I spelled that right, all right? And anything below 7 represents acidity. And so we represent alkalinity in terms of pH about with hydroxyl groups. So what's the concentration of our hydroxyl group, all right, to determine the alkalinity of the solution. And with acidity, we represent it as a hydrogen plus cation concentration. All right, so that's that. And now what we said here below, now or above, we can see why it's true, because if we have a higher concentration of hydroxyl groups than we do H plus cations, then we know we're on the alkalinity side of it, right? We're more alkaline, we're more basic, all right? But if our hydrogen cation concentration is greater than our OH concentration, right, or hydroxyl group concentration, we know we're more acidic, right? We're more on the acidity side of the pH scale. So that's that. Now another thing to know before we end this video is that if you're asked what's the how much more hydrogen cations are present in a pH of 5 than in a pH of 6, Well, so let me go and word it as this way. If you go from a pH of 6 to a pH of 5, you don't increase the hydrogen cation concentration by 1, right? You increase it by 10 times the hydrogen concentration. So what I'm saying is this. So remember, one other important thing to mention, right, is that as you go down, you increase the hydrogen concentration. So you increase the hydrogen cation concentration. Same thing here. As you go this way, you increase not the hydrogen cation concentration, but you increase the hydroxyl anion concentration. All right. So as you go from 6 to 5, you just increase the hydrogen concentration by 10 times. So this is a 10-fold increase. All right. As you go from 5 to 4, another 10-fold increase. So that means if you go from 6 to 4, you just straight up dip, right? Don't even care. You just increased by 100 times. 100 times, so that means a pH of 4, that would mean a pH of 4 has 100 times more hydrogen concentration than a pH of 6 does. All right? So the pH of 6 gets that, all right? So that's what that means. So it's a 10-fold increase. So it's a logarithmic based scale when you're talking about a pH scale. Let's go over to the other side. What happens when I go from 8 to 9? Here you increase the concentration of hydroxyl groups by 10 times. All right? What about from I don't know, 10 to 11? Again, the pH of 11 has 10 times more of a concentration of hydroxyl groups than a pH of 10 does. All right, so it's going to label that. Now, if you say how much more does a pH of 14 have than a pH of 12, right? How much more of a concentration of hydroxyl groups does a pH of 14 have than a pH of 12? That's going to be 100 times more. All right, so the pH of 14 is going to have 100 times more concentration of OH than a pH of 12 does. All right, so that's how the pH scale works. So it's a 10-fold increase for every one difference. All right, it depends on what you're talking about. If you're talking about the alkalinity side, it's 10-fold increase in OH. If you're talking about the acidity side, it's 10-fold increase in H+ as you go this way. All right, guys. So yeah, that was what I wanted to get through this video. That's what I wanted to get through this video. I really hope this video made sense to you guys. I really hope you guys got a basic overview of the logarithmic scale-based pH scale. And actually, sorry about that. I just remembered one thing is that will be useful for our future acid-base calculations is that pH, so the pH plus the pOH is equal to 14, right? Because any number you choose here and you add it, it has to be equal to 14, all right? Because if you choose a pH of 5, right, then that means the pOH is going to be 14 minus the 5, all right? So it's going to be 9, all right? So that's another important equation for later acid-base calculations, all right? That we'll use to find either the pOH or the pH. All right, so we know that the pH and the pOH, no matter what number, has to add up to 14. All right, so again, if the pH is 2, then that means the pOH, right, or right here, the pOH has to be 12 in order to add up to 14. Again, if the pOH is 12, then that means the pH has to be 2, right? Because our whole scale is from 0 to 14. It has to add up to 14. All right, so that's the end of the video. So I hope this video made sense to you guys. Thank you for watching. Make sure to tune into my future videos for more cool topics about biochem, physics, and chem. Hit that notification bell, like, subscribe, and see you guys later. And stay safe.